So here is another example. As you can see, it says show that summation of I square is equivalent to n into n plus 1 into 2n plus 1 over 6. So here again, we apply the 3 steps to solve this problem. So our first step here, or first part, is the base case. So for the base case, we say P of n is equals to the summation of this n to I square n into n plus 1 into 2n plus 1 over 6. Okay, for the base case, we said what? For P of 1 element. So P of 1 is equals to, this is 1. I here, I is equals to 1 and n is equals to 1. Okay, so I, which is 1 square, is equals to, instead of this n, I will say 1 into 1 plus 1 into 2 into 1 plus 1 divided by 6. So forget about this one now. We just consider these two, the left and the right. Okay, so here now we have 1 is equals to 1 plus 1 here is 2. So 2 times 1 is just 2 into 2 times 1 is 2 plus 1 is 3. So 2 into 3 divided by 6. So this now becomes 1 equals to 6 over 6, which is 1 is equals to 1. So for the base case, we have shown that this element is 1. Okay? So now let's come to the second step, which is inductive hypothesis. So for here, we let n equals to k. So since you have here p into n is equals to the summation of n I square, which is equals to n into n plus 1 into 2n plus 1 over 6. Okay? Over 6. So now we replace this one n to k. So p of k is equals to the summation of k, I equals to 1, I square, which is k, is equals to k into k plus 1 to 2k plus 1 over 6. Okay, so that's the second part. Then the third part, we'll check for the highest element. Highest element. For the highest element, we say k is equals to k plus 1. We give an increment of 1 to k. So here, p of k plus 1 is equals to the summation of, instead of k now we say k plus 1. Okay, I equals to 1 here to I square is equals to, this now will be replaced by k plus 1. So where you see k, you add plus 1. So k plus 1 for this first one, let's close this bracket. And this k here is k plus 1 plus 1. Okay, into 2 into this k again is k plus 1, then plus 1. Okay, But this I square now becomes, this I square becomes k plus 1. So k plus 1 square, take this one outside here, k plus 1 all square, because this I is equal to k plus 1 all square plus the summation of this one, which is k, the summation of k into I square is equals to, then we take this one, this whole equation, k plus 1 into k plus 1 plus 1 into 2 into k plus 1 here over, this one is over 6, yeah, over 6. So let's continue here. So from here, we consider first this one, we try to expand this, or we first try to eliminate this one here, because this equation I square summation of k I square into I equals to 1 is equals to this equation. This one is equals to this. So we replace this by this equation. So k plus 1, k plus 1 k plus 1 all square plus the summation. Instead of this summation, I will replace this. Is k into k plus 1 to 2k plus 1 over 6 equals to, then we take this original equation here. K plus 1 into k plus 1 plus 1, then 2 into k plus 1 plus 1 here. So now we try to expand this equation over 6. Okay, we try to expand this equation, this and this one. So for this, k plus 1 square is the same as k square plus 2k plus 1 plus, then here we first expand this here, this first one, which is k times k is k square plus k. Okay, then add this into 2k plus 1 over 6 must be equals to this. We can expand this first, okay, because we have here k plus 1. You can see the brackets here, so we can say k plus 1 into this now become k plus 2. We expand this here again, which is 2k plus 2 plus 1, okay, over 6. So this k square plus 2k plus 1, multiply this again, plus 1 plus, this is 2k cubed, or if you multiply this by this, k times k is k square plus this one, this is already 2 plus the 1, add the powers, okay, 3. So the coefficient of this k here is 1, the coefficient here is 2, so 2 times 1 is 2, plus, then we multiply this to this plus k square, then we take this again, plus 2k square plus k over 6. And this, again, we try to expand this. You can either first consider this two equation, or we use this two. So for me, let's take this first one. So for this one here, you can further expand this. When you expand this equation, you will get this 2k cubed plus 9k squared plus 13k plus 6. So here again, first you cancel this and this. The denominators are the same. So now this 6k squared plus 2k, 6k squared plus k squared becomes 7k plus this 2 is 9k squared. But first we take the k cube, okay? So 2k cube plus 9k squared, then 12k plus k here becomes 13k plus 6. Now is equals to this 2k cube plus 9k squared plus 13k plus 6. Therefore, these two equations are the same. Okay? So the second part again shows that the equations are equal. So here brings us to the end of the video. Don't forget to like, subscribe on the channel, and give your comments.